Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss photodiode. Let's begin. Photodiode is a special type of PN junction diode which sends to light. A photodiode is a reversed bias junction diode in which reverse current increases when that junction is exposed to light. It is made from silicon or germanium. What is the mechanism? The reverse current in a photodiode that is directly proportional to the intensity of light falling on that of a junction. If the intensity of light falling on that of junction is greater, then the reverse current is greater. On the other hand, if the intensity of light is smaller, then the reverse current is smaller. Let me explain what the physics behind photodiode means. When that particular PN junction is exposed to light, then how the flow of current means the reverse current increases. The reverse current is directly proportional to that of intensity of light. Let me explain it. That with the principle, you have to take PN junction diode which is reverse biased, means P type is connected to negative terminal, N type is connected to positive terminal. In case of P type, the majority charge carriers are holes. In N type, the majority charge carriers are free electrons. When there will be no such application of external potential, the electrons are filled to that of a hole, and here a negative potential developed, as there will be the deficiency in free electrons, so a positive potential is developed. Negative potential, here positive potential, that be the potential barrier. Potential barrier V of B and when we apply an external potential and that PN junction is now reversed bias situation, means P type is connected to negative terminal and N type is connected to positive terminal. So the direction of flow of current from this way, from positive to that of negative, and the flow of electrons from negative to positive, that is the conventional current, which is opposite to the direction of flow of electrons. Now, as here electrons are from positive to negative, so there will be the deficiency of free electrons on N type, and in P type that electrons are pushed, that be the number of free electrons are increased on that of P side. Therefore, the potential barrier gradually increases. Now the potential barrier increases. Inside that of potential barrier, the electric field from N type to P type and that electric field oppose the further increase of free electrons, and there will be very small amount of current flow through that of p-n junction diode, and that current is the reverse current. Then question arises, what be the time duration on which that reverse current flow through that of junction. Look here, if the barrier potential is same as that of external potential, if I take a equivalent circuit, here is the negative potential, positive terminal, there will be negative and positive, here the potential, barrier potential V of B, external potential V. When VB is same as V, then no current flow. When barrier potential is same as external potential, then no current flow. Due to that potential, the flow of current from this to that, and again due to this potential, the flow of current from positive to the negative terminal. The direction of flow of current in both the situations are equal as well as opposite to each other. As a result, no current flow through that of circuit. So, if that barrier potential is small as that of external potential, then the current flow through that of circuit until unless that barrier potential is equal to that of external potential. For that, we have to introduce incident light. We know light is nothing but energy of photon, that is the photon, that energy is equal to h nu, Planck's constant, and the frequency. When incident of light to that of p type and n type semiconductor, therefore the barrier potential now decreased. As a result, the reverse current will flow through that of p-n junction diode. If the intensity of light increases, then the flow of reverse current also increases. All these things that we have discussed here, now we write in terms of principle. When a rectifier diode is reverse biased, p type is connected to negative terminal and n type is connected to positive terminal, a small reverse current is produced. small reverse current is produced, as we say the potential barrier potential is less than that of external potential, then a small reverse current is produced. The reverse current is produced why? By the thermally generated electron hole pairs which are swept across the p-n junction by the electric field created by reverse voltage. That free electrons of n type are combined with that of holes of that of p type, and now a potential barrier is developed and electric field is created from n type to p type. The reverse current is produced by thermally generated electron hole pairs which are swept across the p-n junction by the electric field created by reverse voltage. Then the reverse current increases with the increase in temperature due to increase in electron hole pairs. As electron hole pairs increases, then the temperature increases. As a result, the reverse current also increases. Similarly, when the p-n junction of a photodiode is exposed to light, the reverse current increases with the increase in the intensity of light. Here, the reverse current increases due to increase in temperature. Reverse current increases with the increase in temperature, and that increase in temperature due to electron hole pairs, as we discussed here. In that similar way, when that p-n junction of a photodiode that is exposed to light, the reverse current also increases as the intensity of light increases. When light falls on that of p-n junction of a photodiode, the energy is imparted, the photons, to the atoms in that of p-n junction, and this will produce more free electrons and holes in that of p-n junction. These extra free electrons or holes will increase the reverse current. Hence, increase in intensity of light decreases the resistance of photodiode. All these principles we have already discussed by taking this diagram. Okay. So, the intensity of incident light is directly proportional to the flow of reverse current. What amount of reverse current will be flow, that depend upon what will be the intensity of incident light. Next, the construction of photodiode. Construction. As we discussed, it is a special type of p-n junction diode which is sensed to incident of light. Therefore, that photodiode that is consist of a p-n junction diode that p-n junction diode is embedded in a clear plastic enclosure. That is a clear plastic in which that p-n junction is embedded, and that p-n junction is reverse biased, and p type is connected to the negative terminal and n type is connected to the positive terminal. The potential be negative terminal, that one is the positive terminal, and the light is allowed to incident on that of p-n junction of photodiode, and all the remaining portions of that of clear plastic enclosure are painted black. These are black painting. Black painting. In order to take the only incident light that fall on that of p-n junction. Okay, that is the construction of a photodiode. Photodiode. When we are dealing with photodiode in an electronic circuit, so the symbol of a photodiode, symbol of a photodiode, that is when that p-n junction diode is reverse biased, n type is connected to the negative terminal and p type is connected to, that is n type is connected to positive terminal and n type p type is connected to negative terminal, so it is reverse biased and it allow the incident light fall on it. The inward arrows represents the incident light on p-n junction of a photodiode, that is the symbol of a photodiode. Next, working. Now we are dealing with an electronic circuit at which that photodiode is used. So here is a photodiode. That photodiode a resistor having resistance R connected with series, potential, that n type is connected to positive potential and p type is connected to the negative terminal external potential. Here is the potential V of R, that of photodiode, and the reverse current I of R. If no light is incident on that of p-n junction of a photodiode, then reverse current IR is very small, and this small reverse current is known as dark current. If no light is incident, then the reverse current I of R is very small. This is known as dark current. Dark current. The resistance at that case the resistance is called dark resistance. Dark resistance. that is dark resistance R of R is equal to, here the potential V of R plus the current I of R. When no light is incident, if light is incident, if light is incident on the p-n junction of photodiode, then the reverse current increases. Reverse current increases. What will be the reason? Due to the creation of extra free electrons. The creation of extra free electrons. If the intensity of incident light increases, the intensity of incident light increases, then the reverse current that is I of R, reverse current I of R increases, and reaches its maximum value, which is known as saturation current. When we incident light on that p-n junction of photodiode, then we obtain reverse saturation current. That will be the working of photodiode. Next, applications. As that particular device is sensitive towards light, so it is used in case of alarm circuit, and used in counter circuit. In digital electronics, we know what is a counter circuit. So here, with the help of this video lecture, you understand the concept of photodiode, principle of photodiode, and we understand what exactly that principle is, construction of photodiode, working and applications of photodiode. So, with this useful and informative notes, let me wind up this session. Thank you.